Okay, for these problems, we're going to determine whether the lines given by the equations below are parallel, perpendicular, or neither. So what we're going to look at is the slope. It might even be better if I had labeled this like line 1 and line 2, but anyway, okay, I think it's all right. Let's just say this is M1 is equal to 3, M2 is equal to negative 1/3. We see that M1 times M2 is equal to 3 times negative 1/3, which is negative 1. What do you say? Are they parallel, perpendicular, or neither? I think you know the answer. Come on, speak up to someone. Parallel, perpendicular, or neither?
Perpendicular.
There. One way, thank you, it's exactly right. One way to say it is that M2 is the negative reciprocal of M1. Negative 1/3 is the negative reciprocal of 3. And for this next one, different color. Oh, a little bit not as easy because I have to manipulate this maybe. I have to find the slope. 2y equals negative x plus 1. If I divide by 2, I get negative 1/2 x plus 1/2. So M1 is negative 1/2. For this next one, 6y equals negative 3x plus 12. Divide by 6, I get y is negative 36x plus 12, 6. Y is negative 1/2 x plus 2. So M2 is negative 1/2. Are they parallel?
Parallel.
Oh, I didn't, yeah. Sorry, I didn't write the answer in the last one. Parallel. M1 equals M2, so parallel. This one before, this is perpendicular. Because M1 times M2 is equal to negative 1, or they're negative reciprocals. Negative reciprocals. Okay, all righty, good. Now let's find the equation of a line that passes through these 2 points. Okay, so here we have, we could sketch the graph. That might actually make the whole thing go really quickly. I'm going to do the whole thing algebraically. I'm going to first find the slope. So here's my solution. I find the slope. Slope is rise over run. So this, I'll take the difference in the y coordinates. I'll do negative 3 minus negative 1. So I'll pick up those y coordinates, negative 3 and negative 1, and then I divide by the x coordinates, 2 minus 4. So I picked up those x coordinates, 2 and 4. So the thing is, I don't want to flip them and get them reversed, which I could see myself doing, but I don't think that's what happens. So, okay. Oh man, it's too easy of a number, negative 1, or no, positive 1. That's not so good of a problem that I just made there. But, oh well, that's what I did. Okay, and so then we have our points. You can pick any of those 2 points, which are x1 equals 2, y1 equals negative 3. You could have done the others also. But we have, then I'm going to use y minus y1 equals m, x minus x1. So y minus negative 3 equals 1, x minus 2. So then y plus 3 equals x minus 2. Y equals x minus 2 minus 3. Look pretty good, but now I'm running out of the last line there. Let's just move this down. Y equals x minus 5. Hold on. Why don't I just check and not be super lazy, but you can do a check. You know, why don't I check? Check. Y equals, if I put x is equal to 2. Y equals 2 minus 5 equals -3. Check, it works. How about if I put x is 4? Y equals 4 minus 5 equals -1. Check, it works. So where am I getting those, you know, those 2 and 4? I'm checking the 2 points. X is 2, x is 4, and I'm verifying that I get those y values, -3 and -1. And since that works, that's correct. That's right. Those 2 points are enough to define the line. Okay, any questions about that? Write the equation of line that's parallel to this line given below and passes through 1, -1. So here's my solution. The slope is m equals 2/3. Everybody's on board on that? There's m is 2/3. That's the slope. And our point is x1 equals 1, y1 equals -1. And then I use, also what I could do is conserve space here. Okay. I use, again, y minus y1 equals m, x minus x1. So y minus -1 equals 2/3 x minus 1. Y plus 1 equals 2/3 x minus 2/3. Well, for whatever reason, when I made this problem, I thought I would torture everybody with fractions. Okay. Well, 1 is 3/3, so y equals 2/3 x minus 2/3 plus 3/3. And that leaves just enough space here. Y equals 2/3 x plus 1/3. Well, they're certainly parallel because they have the same slope. And then you can double check. I think maybe I'll just do it in my head, but if I put x is 1.
Hey, Professor, shouldn't it be y equals,
it's wrong.
it's -1 instead of +1?
Yeah, it's wrong. I'm glad I did the check, and I'm glad you told me. Yeah, I was checking. And so if you hadn't told me, then I think, okay, I suppose I would have gotten by the check. Yeah, that was wrong. Okay, this time I really am going to check. Okay, well, I mean, I was doing it in my head, but so check. If I put x is equal to 1, y equals 2/3 times 1 minus 5/3 equals -3/3 equals -1. So that's my check, a little bit messy, but it does check out, and it didn't before. And then I also, as my check, all of you helping me out, thank you. Okay, anything else that you see there?